All right, guys, this is 13.1. This is the chapter on multivariable functions, and we're going to be hitting partial derivatives pretty soon. Tomorrow is the section on differentiability and continuity, which means the videos for delta epsilon. I am not the best delta epsilon explainer. This is not my area of expertise, but I did it. And I linked some other videos in the announcements that are worth watching from people that are much better at than I am. So you get the idea of the delta epsilon proof. I am not going to have you do it for the test. I don't think there's even one on the homework, but it is important to understand what it is, because it's how we justify being able to take derivatives in multivariable functions. Let's do some warm-ups. This section is on doing evaluations with substitutions and contour lines, as we will need the contour lines probably when we get to 13.5 or 13.6, something like that. So go ahead and take a moment, write up f of x of t and y of t, which means you should only have t's left in it by the end. Let's see what humorous shit you guys have been posting in Discord. Jones supremacy made me laugh.
I gotta admit, all those math problems with the different ways of doing it.
I thought the interval that evaluated the pi was pretty cool.
Yeah, that Wi-Fi pass was something else. I wouldn't want to hurry that. It's only two options, either E or either pi. That's the only thing you can get one thing out of 10 digits. Right? Well, 10 digits to pi is one thing, but like evaluating that integral just didn't look fun. I mean, I just streak at. I don't take integral at all. Why taking integral? Yeah, I did. After I finished that, oh, it might not. Then I just like, okay, integral.com. Yeah, it turns out it's pi. Oh, it is pi. Yeah. Oh my gosh. My instant is right. Well, yeah, I guess that probably was intentional too. Oh, no, that's pretty funny.
That's just matter of remembering pi and
3.14159. That's the amount I can remember.
yeah, that's all you need is
so I can remember what 6 digits. How many digits of pi can you remember, Mr. Jones?
3.1415926. That's where I stopped. I think there's another 5.9 in it also, but I'm not confident of that.
at some point. Probably 5.35.
What? I don't know. Why would I memorize pi? That seems like a stupid waste of memory.
Yeah.
What if all of math gets wiped out?
If my life ever depends on me knowing pi to too many places, I'm fucked. And I'm willing to accept that risk. I don't see it as a likely risk, but you never know. Some asshat might play saw with me and say you need to know pi to 1,000 or 100 places, and I'll be in trouble. But I could calculate it.
I mean, there is a song for that. There is a pi song.
It's better to be able to derive your answer from what you know rather than
No, I can't.
just knowing.
All right, so what did you guys get for f of x of t, y of t?
Why is that? But some of them I can
Oh, so what did they, the pi series, isn't it?
Yeah, I guess on the.
Oh, wow, no. What?
Talk about their. CSI. I don't know what to do.
No, yeah, well, no, I'm remembering how to derive
I
pi,
got
it's from pi series. Yeah. I know.
Oh, yeah.
Minus
That's-
4
that's
over
good.
3 plus
And then he's plugging
4
numbers.
over 5. Yeah,
Keep going. So it's-
yeah, I remember
I thought there
very
was more. I thought there was like the
I remember when we had to do that. I did that. I was in Calc 1. It was like, what?
Why would you be done doing that in Calc 1?
No. When I was in CSI 1, I was in Calc 1.
Oh.
So like when we did the Taylor series, I was like, what the hell is this? You know?
I thought that was really cool.
Is that what you guys got?
Yeah.
All right, so f of 1 should be pretty easy. They should all be pretty easy, actually. If you're lazy and you don't want to calculate it. F of 1, f of 1 we can calculate. That's pretty trivial.
I just didn't want to be wrong.
1 squared plus 3 times 1 to the 10th is just 4. F of 2, though, is a little bit more. And we can get a calculator. Starts getting to be calculator work pretty quick.
Would it be correct to call it
There's
F
a 10
or less than 8?
plus 4. I'm getting 3076 on that one. Oh, what's F3 look like? We got 3 squared plus 3 times 3 to the 10th, which is 9 plus 3 to the 11th. Not as big as I thought it would be. Huh. Okay, that was just a warm up. I got a much more fun one for you. Are you guys ready for it? Let me give
Yeah, that's
people another minute to write this stuff down.
Are those two numbers? Or those just the two from different different.
Which one?
That's two answers. Dude. Are those just the
Oh,
different values? Yeah.
the 3076 and the 177,156. Those are
Oh, never mind.
different.
That's one number. I saw a comment. I was like, I thought those
Oh.
were one number.
Like I'm evaluating at the times, like it was us. Everyone
No,
ready?
Yes, sir.
Let's do it. Let's bring the magic home.
Oh, fine.
Yeah, multivariable inception. Multivariable function inside another multivariable function. What?
Great.
Oh, well. Mr. That's
What? That's some good
so-
shit.
People are just whispering, but Mr. Jones,
Right?
you're making it.
Mr. Jones. Well, I could make it worse. It could be 3 variables. I could add in a W of X, Y, Z. Oh, that sounds like a good
all
idea.
in due time.
Let me write up
It's
another
okay.
prompt.
All in due time. They will.
Nope.
They will find it soon. Don't worry.
They found it right now. I'm doing it right now.
Oh gosh. I'm so confident. No, that's really happy. Thank you, so awesome.
Look at this. This is deep. Oh God, this is gonna hurt. This should be on a test. That's just devious. Why would you do to that then to them, Mr. Jones? If you don't believe me, you can ask James. Math teachers sit at home and think of ways to torment their students. This is what we do. It's one of our passions in life. We get it kind of sick pleasure out of it. I'm just willing to admit it. And you know what? It's making me feel a little bit better about my dog dying. I'm not thinking about my boy right now. So I'm gonna think I gotta do that. I might start planning your next test. See how challenging I can make it.
Yay.
That's the right answer. Yay. Confused, Mr. Jones. Please do it again, Mr. Jones. Make it harder, Mr. Jones.
Everybody said, "Oh."
All right, so I'm assuming you guys got to at least this point. We got G, we gotta plug in U and V for X and Y. So G is, I got B, and then sine, I guess I don't need this parentheses. B times sine. X is U, so we'll do U squared and then V. Now we gotta start plugging shit in. U squared is going to be X squared squared, Y cubed squared, and then we're going to multiply by B. So maybe I'll make that parentheses look bigger. And then we've got pi XY. I don't want to put UV, I want to put U of XY, V of XY. Equals, let's clean that bad boy up. I've got sine of pi times, I got X squared squared is X to the fourth plus another X is X to the fifth. And then Y cubed squared is Y to the sixth plus another Y is Y to the seventh. So where does spell where or does with a GOE? That doesn't make any sense. Where does G equal 0?
I'm hearing someone say if X or Y is equal to 0.
Those are valid answers. Let's write those down. Those are not it. When I mean not it, those are not the only answers.
Yeah, what else? There's whatever sign is.
Wherever sign is 0, where is sign 0?
0.
Pi or 2 pi.
Where,
Or any
Yeah, sign-
integer multiple of pi, really, right? Sine of
Yeah,
3
so-
pi, 11 pi, negative 6 pi.
It would
Yeah.
be any integer value.
So it's also going to be for if x and y are both integers. And I don't know if there's any combination of fractions that would make x to the 5th and y to the 7th make an integer. But there might be. Well, yeah. What if x is 1/3 and y is 3? Then I got 3 to the 7th on top, 3 to the 5th on bottom. I got 3 squared. It wouldn't work the other way around though. Y equal or x equaling 1, x equaling 3, y equaling 1/3 would give us a 1/9 pi. That's not going to work. So it looks like maybe if x equals 1 over y.
That should ban this question.
That's a pretty good question. I like that. That's pretty good. I don't know that there's any others, but there might be. Especially if you get into some like complex number theory, but we're not doing that. That was just a funsy. Wasn't that fun?
Sure. That was interesting.
It's a blast.
That's right. It was a blast.
As point deducted, more like a blast from the past.
Oh, yeah. If x equals 1 over y and y is an integer.
No, it's not like this, but you're like. This.
If y is like 2/3, that's not going to work.
Better question is where is it not 0?
If both of them are fractions, that will cause them to not be 0.
Right? It looks like y basically has to be an integer, and then x can be an integer or 1 over y. Anywhere else is not going to happen. You guys ready for a even better? Inspired by this one?
Oh, well,
Inspiration is flowing.
Oh, triple
Gosh.
variable,
Oh,
triple variable threat. What? I don't even know how this is going to look. I might have gone too far. This is what happens when you have a pen and some artistic thoughts, and you just run with it. This might be much harder than I think it is. It doesn't look too hard to me though. Just a lot of tedious tracking of variables, right?
I mean, at least you're not asking them to put it in terms of U, V, and W. Because that's actually what I initially thought you were saying to do.
Doing it in terms, what do you mean?
Like you, instead of having of H of X, X, Y, and Z, you were saying to put it in terms of U, V, and W. But I'm
That's
like
what I am
thinking,
asking. I want them to plug in U, V, and W into H.
Well, not plugging, that's not what I meant. I mean, like, in terms of like saying the Jacobian, which they learn a lot later, now that I think about it. Oh,
You've gone crazy.
I'm like, wow, this is interesting.
So a good spot to start is making sure you set it up to look right in the beginning. So let's just. So I need my x's to be u's, so I'll have a u squared there. And I'll leave the cosine alone. I'll write that down right now. We got a fraction, we got a plus sign, I got a cosine. And I'm putting in u here as well. And then my v's, use colors. V goes where y is, so I got a v down here and a v right here. And for z, I'll use green. Z is my w.
Yeah, we're.
I actually can't. Nice.
So we're squaring this. And we're not doing anything with it right there, so I'll just write it in. And my y is my v, xy over z squared, xy over z squared. And w squared is
That last one's squared as well.
yeah, I bet. Thank you. All right, well, I can move this z squared to the top. That's from this z squared. And then I've got x cubed squared is x to the 6th. Y squared, off screen, y squared squared is y to the 4th. And then z squared plus, all this is over xy. And I've got z to the 6th over x to the 4th y squared. Does this clean up at least any somewhat? Let's see what we got in here. I've got x to the 4th y cubed over z times z to the 6th x to the 4th y squared.
X to the 4th cancel.
That's convenient, right?
This is crazy good.
So I'm gonna move this XY out here and get a common denominator. I've got x to the 6, y to the 4th, z squared. I'm gonna multiply this real quick. Well, I don't know how quick it is. By y or x to the 4th, z, y squared over x to the 4th, y squared. And I still got z to the 6th. And now inside, we get it kind of cleans up quite a bit. The x's cancel, the y's reduce. It looks like I just have yz to the 5th. Is that right?
That looks right.
That's not too bad.
Because there's a Z on the bottom for the other one.
To get X.
Oh, that's awkward. Okay, I got all her questions on. Awesome.
I don't think it gets any cleaner than that.
It looks beautiful. Oh, I guess you could actually still factor out another z squared for the
You're right.
from one.
You're right, I could. Let's do that. So this was squared. We're pulling out the be z to the 4th. There's no z here now. That was z to the 6th, so that's z to the 4th now. Yeah.
Remind me to like find these problems later, like these types of problems later on. It's good algebra practice.
Right? Why, oh, why would Mr. Jones say, let's do something like this? Well, where we're going with this is we're going to take partial derivatives. And so sometimes you're taking partial derivatives of functions in functions. And while this was a little extreme, triple variables inside other triple variables, it is doable. And so when you do it, you have to kind of do the chain rule. When we do a partial derivative, we got to do the derivative of the outside, then the derivative of the inside. And you'll see how partial derivatives work on Thursday after the exam. You guys ready for another little piece? That wasn't too bad. That only took 10 minutes. That was disappointing. That wasn't hard enough, was it, James?
It wasn't, honestly.
Just a lot of keeping track of shit, but it wasn't a challenge. You just got to go slow. You can't go like Speed Racer. Oh, that would hurt James so bad. I'm going to slow him down. You're going to have to take full time on his test next time. I'll just have to do a lot of tedious shit in there. I can slow James down. And everybody else will hate James for it. But Mr. Jones.
Mr. Jones.
Are you guys ready for another one? Anyone still need this up longer?
Not sure where. I made a mistake somewhere.
I hear voice, but I don't know if that was a yes.
No, I got it.
Okay.
Figure out what
So let's skip on to the other topic in this section, contour lines.
I just checked that and then the one that.
So,
Big square. Big people in the bottom and then
Please, yeah.
Multiply it here as well.
Slide one.
So.
I feel that, Eric.
When you simple both. You apply it for this one as well.
We need to try that. We should put that. I just pulled out. I just pulled out this whole thing.
I squared y.
Because this whole thing multiplied by one is that. But you pull these sides. One over this. It's like it, and then I see multiplied. That whole this whole thing. I just multiplied it out inside here, and then I multiplied.
Press you, sir.
You need to kind of for this as well.
I heard, sir, what? What's up?
Actually, you would be. Because you're kind of reciprocating. They can't do it more.
But I pulled it out though. But that's legal. Being multiplied, the product is being multiplied by, this is being multiplied by 1 over the third.
Wait, what did you call it?
Simple that.
Oh,
And that's being multiplied by that. Because it's on top.
Oh, when you did by the debt. Oh, I'm sorry. Okay, and then that was each year. Looks like you just simplified it a lot more.
Oh.
That's probably why.
It's kind of simple.
Yeah, because what he did was he multiplied this number this here to match this, so you could take it out to make it more simple. That's all.
We commented with the
He,
common denominator.
yeah, that's all he did. He just made it a little simpler. That's all. Welcome to Algebra.
It's more sketch level.
Sketch level curves. Level curves.
I don't
It
think I
is-
want to use -2 and 2. I think -4 and 4 would be better.
Yeah, I'd say so. I don't know why they call it.
Change those to -4 and 4.
I saw it gonna be a 3D.
Oh yeah. I guess it.
One by one?
Well, we don't need to do it in 3 dimensions, I don't think, since we're doing level curves. We don't need to do this in 3 dimensions. It's
No, we're
because
just
it's
gonna sketch them all on this and we're gonna label the different curves,
yeah.
which Z levels they are. And I think starting with Z equals 0 is probably the best choice. If we start in the middle with K equals 0, I've got, and K is Z, right? That's in the, when Z equals 0, K is 0. I've got 0 equals X squared minus Y squared. So Y squared equals X squared, which means Y equals plus or minus the absolute value of X. It's going to be easier if I put little dots.
What's that look like?
So orange will be my K equals 0 curve. I think doing the positive ones after this are a little bit more beneficial just because we're not dealing with the negative. So what happens when K equals 1? What is x squared minus y squared equals 1? What kind of shape is that?
A circle with radius 1. Oh, no,
So close, so close.
ellipse.
No.
Further
that one.
away.
Yeah.
It is minus y squared. It is not plus y squared. Plus y squared would be a circle.
If you graph the,
What other geometric shapes do we know? Don't make me ask James. James is my last resort. Or Benjamin. I think, is Ben in there? I can't see him.
Oh.
Ben likes to show off. Ben, what shape is x squared minus y squared?
I'm sorry, Lawrence.
That's a hyperbola.
It's a hyperbola. Up and down or left and right?
Sorry, Lawrence.
We'll let you answer this one,
Left and
Lawrence.
right.
Or not.
No.
Should be left and right. X squared is the positive one. Oh, shit. That looks just bad.
that was x squared, x cubed.
So what about k equals 2? Or 4? Sorry. We have x squared minus y squared equals 4. So we'll put those over 4 and make the right side equal 1. So this is of the form x squared over a squared minus y squared over b squared equals 1. We have foci at c when c squared equals a squared plus b squared. So c squared equals 8. C equals 2 root 2. What is 2 root 2? It's less than 3 because square root of 9 is 3. Square root of 8 should be a little bit lower. About 2.8. Which means we have foci out here.
That's the morning three, right? Oh. What?
No, sorry, talk to myself.
It's marking morning 1, 2, 3. Morning 3.
Our k equals 0 line actually acts like our asymptotes for the hyperbolas, which is nice. Because I don't need to draw in the asymptotes, so they're already on the board as curved lines. So this is k equals 4. Blue is k equals 1.
You draw it wrong.
No, I got that, but
What's wrong?
it just kind of drew you put the point like beyond gray.
Oh shit, you're right. My bad. Let's try to erase out some of that stupid shit. I didn't see the black line underneath the blue because I was. I guess my blue line isn't even in the right spot either. C should be square root of 2, so it should be just a little bit to the right of that. Square root of 2 is right about here. I ain't gonna lie, I had to look that up. I didn't remember what C or the foci. James, did you remember it? You have hyperbola, or Ben? You guys are the show-offs in this class. Eric, did you guys have the formula memorized?
I don't even know that English.
So hyperbola with x squared over a squared minus y squared over b squared. The positive one shows you the major axes, which way the thing opens. So since x squared is the positive one here, it opens in x directions. And then you make a box following y equals b over a, I think. Yeah. You do y equals plus or minus b over ax, make lines. You make a box. The box helps show you where the asymptotes are. So these are the asymptotes for a hyperbola. And the vertices are at, oh shit, I'm gonna fuck that up. I completely fucked that up. Let's get rid of that blue and green line. Let's redo the blue and green line, I should say. Just to make it look accurate. So the foci are what are like the parabola's foci. They're not actually on the line. So we'll redo blue. Blue's foci is at square root of 2. Because a squared plus b squared is 2. We take the square root, that's the foci. We go out left or right, plus or minus 2, or square root of 2. The vertices are actually at A and B. Well, A. B if it's the first one, if it's the positive one. So it is like that. So the blue, the little dot is just like a focal point. Same thing with the green. The focal point is right there and right there, but the curve is actually at the square root of 4, which is at 2. So the vertices are right there.
Mr. Jones, you marked it beyond 3 again.
I'll get over it.
I like that answer.
I'm not even worried about it at this point. Everything else has been wrong with the graph 16 times.
2.8.
This one was right. There we go. Happy?
Eric is happy.
Yay.
What happens with doing -4 and -1 for K? It just makes it so that this entire thing goes the other way. So like if we did -4, we have x squared minus y squared equals -4. So when I divide by -4, the y squared becomes the positive term.
Okay. So it's up and down.
So it's going to go up and down. So that's my K equals -4. And the, I guess we'll go with brown. I'm running out of colors. K equals -1 is there. Wasn't that fun? Aren't curve lines fun? Contour lines fun?
Say it again.
So where does this show up in real life? Look at a weather map, pressure map. A pressure map for in the weather shows pressure lines that are like this. Isothermal lines do this when we do measure the temperature in regions. We have contour lines and usually use coloring with thermals. So we do these type of contour sketches for a lot of shit. I strongly recommend you take a look at the book. They got some good, neat looks at the contour plots so you can get an idea of how crazy this shit gets.
Nice.
That's in 13.1.
Yeah, that's the serve. I just get over.
Other than that, have a good day, guys.
I'll be holding
keep
my
it up,
regular
Bill.
sides today from 12 to 2. Or anybody who's interested in coming.
All right, see you, Mr. Jones.
Have a good day,
See ya.
Professor Jones.
All right.
All right, see you later.
See ya.
See ya.